Hello everyone, and welcome to the new video of the design of a bridge which we did, which is structurally stable, and you can keep brick on top of it. So here is how the design and the structure works of it. So first, when I started to design, it was a normal column and a series of beam, uh, four columns, and the beam which is connected all the way to uh, the supporting structures. So this was the first basic plan which started. The column was was very way too simple, so it was a normal box uh, which was usually being seen everywhere. So later, when I wanted to turn it out into aesthetically and also structurally stable, I took a new design form, that is shifting of the column, or giving a projection. So the column which I given this bridge is in metrics we can say it as so 3 centimeters. So in that this 2 centimeter block is exactly the column. So this projection is given basically just to avoid this sliding. So this was a project which I designed for the school, design school. So they were gonna test the structural stability of the bridges which were made by the students. So that time it will be kept on the bench, so there will be chances of slipping and breaking down of the bridge. So to make it structurally even more stable onto the sliding floor, this extension was given. So in this elevation I'm going to be showing that. So if this is my elevation of the column, there will be a beam on top of it, so there will be some sort of the tension which is acting upon when the load is given on top of it. So that tension would lead to the breakage of top of the column, and also the normal column would slide away from the surface. So next upon was the beam. Of course, if we have the column which is a series of connection and projection, there was another column same to it. So at this point the beam was to given on top of it. So 3 series of beam will be given on top of it was the plan. So later, when it was about to be executed, we got a problem. That is, if this is my elevation of the bridge, the beam was given some sort of like this. It was very thin, uh, and that was a big problem. And the another big problem was whenever the brick was placed vertically or horizontally on top of it, this was collapsing to the one side wherever the load was. The decision was to give a beam which is connecting each other at a point, so that would give the stress at one point and equally distributed to the column, which is whenever whenever the load is kept on top of this bridge, then the stress point will be at this point. So later on, a series of millboard was joined together and placed in a pergola way. It balanced certainly, and it has been structurally stable. So thank you. have another design process of the another bridge. So as you can see, it is entirely different and structurally even more stable than the before bridge. So the design process evolved from a simple the rectangular box that is a beam and a normal column rectangular. So this was the basic plan which was executed before, but then the design thought something structurally and also aesthetics also. Uh, the other thing was to support this on a single uh, beam and also double uh, column. So it was an easy task. So a simple triangle was taken as a basic form, and inside of it was a small uh, parabola which would be taking the load. So on the second point, we are after getting the cross section, it was about the edges. It was not only the simple thing we have. We need to give some sort of aesthetics. So the framing was given onto the edges of the bridge. That is cutting out this simple column into the cross section. So uh, it would be holding the beam also, and it would be supplying the load all the way to the ground. So the technical issues was the strong base. So a small paper, the millboard is being placed, so it won't get deviated when the load is given. So this bridge is actually capable of taking the vertical and horizontal load of two bricks. So if you place uh, two brick which is the horizontal and vertical, it would take load, and also if you place two bricks vertically, then it's capable of taking the load as usual. So here is a technical aspect of this bridge, how it works and how it is capable of standing in a flat surface. So we have the bridge elevation over here. It's ground, and if you take a brick which is placed horizontally on top of it, I'm gonna place the two of them because it's capable of taking two of them. We have the load which is stressing out on the beam all the way to the down, but this load is supplied all the way to the column instead of tensile or tension which is being applied to this. It's directly supplied to the column. From the column is directly supplied onto the ground, so there will be no bulk or bulge below, and also there will be an easy flow of the load below. So this is the overall design of the column. So thank you.
Hey. Over. One more you want? Brick. Playing.
Protest on another book.
Pass.
Yeah.
No. Slide.
Photo